materials work in NGL, the changes between OpenGL shading language 120 and 150 are exactly the same for lights. So before, when we had fixed functionality lighting, we would use GL Light to enable the light that we wanted to use, and all of the parameters when we used the GL Light FV parameters would be passed to the shader, and they would be used in all of our shading calculations. And we'd have a maximum of 8 lights as per normal OpenGL. Again, this can be seen in the previous shader that we use. So in this case, one that's just using GL Light 0. You can see what we would do is we would access the GL Light 0 ambient, diffuse and specular, and also GL Light Source 0 position, and also the GL Light Source half vector, which is used for the Blin-Phong shading. So these have been deprecated, they no longer exist in OpenGL, and we have to basically pass any lighting information we wish to the shader using our own structures. So again, for these simple demos, what I've done is I've created my own implementation of the light structures, and this is based more or less on the examples that are in the OpenGL Orange book, which is the OpenGL shader language book. So what you can see here is I've got a structure that is going to be passed in with the lighting information. So we pass in a vec forward position, then we pass in the ambient, diffuse and specular values of the light. And within the shader, what we're then going to do is declare a uniform. In this case, it's called light because we've got a single point light in our scene, which I've called light. And what we have to do in the shader is do some calculations to pass to the fragment shader. We need to pass in the light direction. We need to calculate the half vector, which is the Blin-Phong half vector. And also we need to know I direction, which is the direction that we're viewing from, so that we can get proper specular highlights and everything else in our shader. So this is replicated now in the NGL Light. So if we look at the NGL Light class itself, we will see that there is a method now called load to shader, as we have similarly with the material class. This passes in the name of a uniform, which is the name of the light we wish to configure. And the other departure from the way that the lights worked previously when we enabled or disabled lights, this load to shader now determines if the light is active or not. Now, doing if statements on structures in OpenGL SL causes quite a few issues. So to make it easy with the lights, if the light is active, we will set the light parameters with the color values that we've set, positions and so forth. If the light is inactive, all we do is set all of the shader parameters to 0. So they have no contribution. So we still do all of the looping through lights and accumulation of light, but what we're doing is we're doing that with a light that has zeros, which means the maths basically turns the light off. So what happens in here is we will pass our uniform, in this case it's light, and light.position will be set to the position we've set for the light, and similar for ambient, diffuse and specular color parameters. What we also have to do when that load to shader is called, so here we've done the mlight load to shader, is we need to actually go through and start calculating our half vector and other things that we need for the light. So in the main shader here, we calculate our I coordinate, which is basically taking in the current vertex and multiplying by the model view matrix. More on that in a little while, I haven't set those yet. And we calculate our light direction by subtracting the light position XYZ from the I coordinate. We then go through and a bit later we calculate our world position here, which takes the modelling matrix and the current vertex, and we can then calculate our light direction by subtracting the light position from the world position, calculate the distance of that, so we just calculate the length of the vector, we divide our light direction by that, and then we can calculate our Blindfon half vector by from adding I direction to light direction and normalizing that value. And then that's used a bit later in the actual calculations for the specular highlights, and that gives us a nice highlight. Now, there will be lecture notes on how all of this works, so I don't want to dwell on it too much. And that is basically how we configure materials and lights in GLSL. We have to pass all of these values into our shader, and again, this is a major departure from how it used to work in GLS in NGL 4.0.